Let's take a closer look at this function I created right over here, getHealth. The rules of how functions work is pretty much always the same whether you're making a plain old function just like that or whether it's a function that's part of a class, which means it's a method of a class. So all the rules of scope and stuff like that apply. Right over here you have to make a return type, so over here the return type is integer, over here it's void. That's why this function over here doesn't have to return anything, but this function over here must return something. And whenever you call this function over here, that evaluates as an expression, and you can take advantage of that expression and use it for something else in your line of code. So for example, if you're ever going to use a dot get health, whenever you call that function, since that function returns an integer value, you can take advantage of that and put that inside of some variable of the same type. So because getHealth returns an integer and x is an integer, you can give whatever is coming back from this function getHealth into the variable x with the assignment operator. Or of course you can perform any sort of mathematical calculation, like whatever the number that's returned from getHealth times 2, wrap that up in parentheses, and give that results to the variable x. But of course, to be able to call this function getHealth, you have to have an actual instance of the class Ogre to be able to call that function upon. So now that A exists, I can use A and access its public functions, and so I can use the function getHealth. I can't use the function getHealth just like this because it belongs to a class. The only way to access functions or methods that belong to a class is by calling those functions upon instances of that class, like I'm doing right over here when I call a.getHealth. So pretty much everything we're going to learn about method functions is the same for regular functions, and anything we'll learn about regular functions is pretty much the same for methods, class methods. One of the differences are, like we just learned, that a regular function can be just invoked, it could be called right away, just like that. A method of a class can only be executed by using the dot operator on an instance of that class. Otherwise, it's as if that function doesn't even exist. Now we're getting a clearer picture of what I told you in a past video, that in C++ you don't only have to use the commands that are built in, but you can create your own commands and your own programming keywords which can be useful to use in your program. One of the things that I've been talking about is creating your own functions and creating your own classes, your own variable types, which makes programming in C++ a lot easier. It provides you with a lot of shortcuts so that you don't have to use thousands and thousands of integers, but you can make classes which combine together a whole bunch of integers and functions, and which makes programming in C++ a lot easier. As a matter of fact, many of these header files which we will be using later on, one of which we've been using right until now, the IOStream header. The IOStream header is a file which other programmers have programmed, and in there they have created lots of these functions and classes. As you see right over here, they created a class, and inside of it there are different functions, and these different classes and functions which these other programmers have already created are pretty useful for yourself, just to include that header and to start using that stuff. For example, what we've been using the whole time, cout and also cin, these are really objects, these are classes which have been created in these files over here. Right over here we see cout and cin. Who are these programmers that created these useful functions and classes? Well, the C++ programming language has been put together and fixed up by the ISO, the International Organization for Standardization. What's useful about that is that wherever you go in the world, whichever C++ compiler you may be using on whatever operating system you may be working, you can be sure that you will always be able to use the same type of stuff as long as it's part of the C++ standard. The standard decided a whole bunch of rules which must be followed by everyone who makes a C++ compiler, so that programmers can depend on those rules and rest assured that things will be the same wherever they go and whichever compiler they use. For example, it's part of the C++ standard that int is the way you create a integer variable. If there's a compiler out there in which int doesn't make a integer variable, but let's say it makes a float variable, then that compiler isn't a good compiler. You shouldn't be using it. It's not following the C++ standard rules. And if you type up code which always follows the rules of standard C++, you can rest assured that your program will compile and run with no problems whatsoever on any other compiler on any other operating system which follows the rules of standard C++. Throughout all my videos, I've been trying to teach you only that which is pure standard C++. Anyway, those same guys who put together the standard rules of C++ also typed up a whole bunch of useful header files, like this file over here, IOStream, which contains a whole bunch of useful standard classes and functions which we will be making use of a little bit throughout the videos, such as the cout and the cin objects. This is known as the standard library, which is going on all of the many header files like IOStream and many others, which were programmed, typed up by the creators of the C++ standard, and provide us with a lot of useful objects and classes and functions which anyone could use. Here on msdn.microsoft.com, which is a very useful website, by the way, if you're programming in C++, we see over here about the standard C++ library a whole list of all the different header files which are provided by the standard library, and which most of the time should come included with any compiler program that you may have. And these files should already be found somewhere on your hard drive when you've already installed your compiler program. By the way, you should be aware when using this website, because many of the stuff mentioned on this website is not standard C++. Microsoft Visual Studio, like the compilers which I've been advising you guys to be using and the one that I'm using right over here, has lots of stuff and functionality which is not standard C++. So it's no problem to use that stuff, just you should remember that that stuff will only work with Microsoft Visual Studio compilers, and it won't work with any other standard compilers. But if you stick to the rules and keep on using only that stuff which is standard C++, then that should work perfectly okay with any other compiler that may ever exist which follows the C++ standard rules. So when you read on these websites about how exactly the standard functionality of, for example, cout works, and you read that this is how you print stuff out to the screen by using this output operator right over here, then you can be assured that whatever compiler you're using, whether it's Microsoft Visual Studio or any other compiler which follows the rules, it will always work in the very same way. You will always type cout, and you will have the output operator, and you will always have a file which is named IOStream, which you will have to include, and everything will work pretty much in the same way. So that's a little bit about standard C++ and the C++ standard library. Here's a class which I once created. It's about a character in a battle game. It had private variables like its name, its strength, its experience, functions like buy weapon and buy armor and stuff like that.